All right, we're going to need a couple different color pens, so have those handy, and then a ruler will probably also be necessary for these notes today. So you just did the study guide on the 1.7.1, 1.7.2, and we're starting with a couple new vocabulary words, but at the same time, these are technically not supposed to be new vocabulary. They're supposed to be review from middle school or math 1. So let's see if you recall some of these words. So the first word that's going to come up in this section, complementary. And complementary means that two angles add up to 90 degrees. So picture I've got some angle over here and some angle over here, or they could be touching or adjacent, but that these two angles have measures of 30 degrees and 60 degrees. So I could technically say that 30 plus 60 equals 90. So we could say that these angles are complementary. Hopefully this is a word that you do recall from past geometry lessons. Likewise, the word supplementary is when two angles add up to 180. And so just like we did on this one, you may have some angle that is 95 degrees and another angle that is 85 degrees. And these two angles, 95 plus 85, add up to 180. And so two angles are said to be supplementary if their measures add up to 180. So these were not on the study guide, but they're expected for you to know. So I just wanted to bring it up. The second thing is some notations. Some notation we're going to need here are a little tiny angle sign. When you see a little sign like this, it means angle. When you see the M angle, it means measure of an angle. And finally, when you see this symbol, it stands for perpendicular. So these little symbols are going to pop up as well. Okay, so let's talk about the actual vocab that's in the study guide this time. And it starts with linear pair and vertical angles. Okay, so what is a linear pair? Let's grab that ruler. And let's go like this. Picture having some line segment. Now, why do I know this is a line? Sorry, not line segment, line. Notice it has arrows on the end, and this starts to matter in geometry, whether there's arrows, meaning it goes to infinity, it's a line, or if it has dots at the end, it means it's a line segment. So this happens to be a line, it goes on forever. And then we've got some ray coming out. And so a line has two arrows, and a ray has one arrow. So again, two more little vocabs here. Anyways, in this little picture, we're talking about angle A and angle B and how those are all, they add up to 180 because they're on this straight line. So we could say that angle A, or the measure of angle A, plus the measure of angle B is equal to 180 degrees. Why is that true? Because they're on that line, they form a linear pair. So the reason we would put is that linear pair is supplementary, or linear pair equals 180. So this is our reason or our justification that we can say that angle A plus angle B equals 180. Well, let's go look at this other relationship, vertical angles. All right, for this one, we could say angle C and angle D are vertical. What does that mean? It's the angle that's across from each other when formed by two intersecting lines. So angle C and angle D are vertical angles. Angle C and angle D are vertical angles. And therefore, we can say that they're equal. Measure of angle C is equal to the measure of angle D. And the reason is that they're vertical angles. They are equal. This is the rule that we know about vertical angles. Well, you might be thinking, wait a second, what about those other ones right there, Ms. Sanchez? Okay, let's go mark those. Let's call this angle E, and let's call this one angle F. And we could also say that angle E and angle F are vertical angles, and therefore they are equal. So measure of angle E is equal to the measure of angle F because they're vertical angles. Okay, now what also is going to come up that's not taught in the study guide, but every once in a while there is some line and it has more than one ray coming out of it. And in the study guide, they only talk about linear pair, but then in the checkup, they do some examples with three angles. So for example, this one here might be 30 degrees. This one here might be 80 degrees. And they're asking you for this one here. So we can tell that this is still along a straight line. And we can say that the measure of this angle here is equal to, I'm going to call this angle X. Measure of angle X is equal to 180 minus 80 and minus the 30. So I could say that the measure of angle X is equal to 70. But my reason for this would not be linear pair because a pair means two things. So technically the reason for this, there's a couple things that people use for this. You could say that a straight angle equals 180 degrees. What's a straight angle? It's this line here equals 180. Or you could say adjacent angles that form 180 degrees. So this could be a reason, or this could be a reason. Since technically it's not a linear pair, there's more than one adjacent angle that we're having to sum up to the 180. So this does not come up on the study guide, but it is referenced in the checkup practice problems. So I just want you to be prepared for that. Now, what are the kinds of problems that they're going to expect us to do with these? Let's go take a peek. All right, grab your rulers and let's draw three lines. And these three lines are not perpendicular. And we're going to call this point A, point B, C, D, E, and F. And let's call the center V your vertex. Now, after you draw this, I want you to label a couple of these. This first angle is going to be angle AVB. The measure of angle AVB is 22 degrees. It's being given to us in the problem as the measure of angle AVB is equal to 22 degrees. So where does this angle name come from? It's a three-letter name where the center letter always needs to be your vertex. So I could call this angle AVB, or I could call this angle BVA, but it needs to have the V in the center. Now, second, I'm going to be given that this angle over here is 64 degrees. This one is that the measure of angle BVC is equal to 64 degrees. Now, it's your job to find all the other angles based on what we know about these. So we're being given two. We're now going to find the rest. Okay? So here I go. The first one I'm going to try for is this guy right here. Now notice that this is a straight line, and we've got 22 and 64 and our angle. So I'm going to call this the measure of angle CVD, and I'm going to use the fact that adjacent angles form a right angle. So here I go. Adjacent angles form 180 degrees, or straight angle equals 180. So either of these two things can be written as your justification for finding that the measure of angle CVD is equal to 180 minus the measure of angle AVB and the measure of angle BVC. Ms. Sanchez, am I going to get points off if I don't write the little m, if I don't write the angle symbol, if I don't write the letters in the correct order? Correct. All of this notation matters for you to get full points on the assessment next Thursday, Friday. So measure of angle CVD is equal to 180 minus the 22 from right here minus the 64 from right here. So we get, hopefully when you subtract that on your phone or your calculator, you get that the measure of angle CVD is equal to 94 degrees. Because adjacent angles form 180 or straight angle equals 180, that's my reasoning. Why is it not linear pair? Because it's not a pair. It's three angles on that line. Okay, now I know that this one is 94, so I can also go get this one. Because the measure of angle AVF is equal to the measure of angle CVD. Why? Because vertical angles are equal. Okay, so measure of angle AVF is equal to 94 degrees also because vertical angles are equal. Okay, now let's go do across from this guy. Across from here, we're doing, and again, you can call it EVF or FVE. As long as the V is in the middle, you're good to go. So measure of angle EVF is equal to the measure of angle BVC. Why? Because vertical angles are equal. So EVF is equal to BVC, which we know is 64 degrees. So there's our angle. All right, last, we're going to go do the final angle. Do I have my pink highlighter? I don't, so I guess I'll go pink pen. We're going for this guy here, and we can see that it's a vertical angle. So measure of angle DVE is equal to the measure of AVB. And why? Because vertical angles are equal. All right, so DVE, we know that DVE is equal to this one, which happens to equal 22 degrees. And that's because vertical angles are equal. Okay, so we just found all the measures. And by the way, you can go write them in the picture if you want to, if you're doing this work on paper. Okay, now, sometimes we're given just straight up angle measures and we're able to identify all the other angles. But sometimes we're given an equation in there and we're asked to solve using linear pair and vertical angles. So let's see two examples of that and how this is going to possibly come up on your quiz as well. So we'll do one of each. And then let's draw a linear. All right, so in the first one, let's write 2x plus 7. In the second one, let's write 4x minus 11. And in this guy over here, let's write 4x plus 16. And let's write x plus 9. Okay, if the direction just says to solve for x, we use the angle relationship of vertical angles are equal to just set these equal and solve. So here I go, 2x plus 7 equals 4x minus 11. And then we use our normal equation steps to solve. I'm going to minus the x's from both sides. I'm then going to add the 11 to both sides and divide by 2. So if the directions just say to solve for x, then this is my answer. But if the directions say to find the angles, you have an additional step of plugging into this. So 2 times 9 plus 7 gives me 25. So this angle right here is actually 25 degrees. Now for this one over here, we go 4 times 9 minus 11, or 36 minus 11, which is 25. Oh, hey, look, they're the same number because vertical angles are equal. So you technically could solve either one. So what did I do here again? I took the 9 from right here that we just solved for, and I plugged that 9 into this equation for x. Then I took the 9 and I plugged it into this equation for x to solve for the total measure of the angle. So if they ask us to solve for x, we stop. If they ask you for the measure of the angle, you have to plug in and get the full measure of the angle. Does that make sense? So these are vertical angles are equal, and that's why I'm able to set them equal. So my reasoning is vertical angles are equal. That's called my justification, my reasoning. Okay, let's go do this one as linear pair. Now, vertical angles are equal, but linear pair are supplementary. They add up to 180. So we're going to write 4x plus 16 plus x plus 9 equals 180. So these add up to 180. So now I just use my normal follow the directions to solve. And by the way, this is if it asks for solve for x. I'm doing the work. So 4x plus x is 5x's. 16 plus 9 is 25. We minus 25 from both sides. And then this gives me 155. And I get that x is equal to 31. So if it just says to solve for x, then I'm done. But if it asks me for the angle measures, I have to plug in. So we go 4 times 31 plus 16, and that gives me 124 plus 16, and that gives me 140 degrees. That means that the measure of this angle is 140 degrees because I took that x was 31 and I plugged it in for x to solve. Now this angle over here is not the same. Unlike the vertical angles that are equal, this is a different angle. So we're going to plug in 31 for x and we're going to get 40. How did we get that? We plugged in 31 for x right here and we added it together to get 40 degrees. So this angle right here is 40 degrees after we plugged in. What else is going to come up on this quiz? Some stuff about perpendicular bisectors. So the last comment I want to make for you guys is when you have two lines that are perpendicular, all we know about this is that this angle is 90. Because these lines go on forever, we can't say that either of these is being bisected. For us to talk about a perpendicular bisector, it actually has to be a line segment, such as line segment AB, with the perpendicular line going through it. So notice that AB has a definite length and that this perpendicular line is going through it. So we have a line here and we have a line segment here. So for example, in this picture, we can say that line, let's go ahead and put some letters, CD. We can say that line CD is the perpendicular bisector of line segment AB. How would I put that into notation? I would say CD with a line with arrows above it is the perpendicular bisector of AB with a line segment over it. So notice the line with arrows above the CD, perpendicular bisector of AB with no arrows. What does bisector mean? It means you're cutting a segment in half. So that means that this is the same distance. Let's call this center midpoint M. This is the same distance as this. If this is a length of X, then this is a length of X because M is the midpoint, because this bisected this little line segment. So line CD is perpendicular bisector of line segment AB, gets lines with arrows on the top and no arrows over this one. Bisecting means to cut in half. So a perpendicular bisector can only happen when there is a line segment with two definite endpoints. Just two perpendicular lines, the only thing we know about that is that they all form 90 degrees. Okay, that's our notes for today.